Hello, in a way, this is going to be part two of my last video that I just put out. And what I wanted to do in this one was to cover some of the things that I wanted to in the last one, but I didn't because I want to keep the videos fairly short. So in the last video, I explained how I calculate the sun's position in three different ways, mainly based on the latitude and longitude of the ground position where the sun is at any given time, or based on the measured azimuth and altitude angles for that location. And what I wanted to do a little bit more in this one was to show a few more examples of that inconsistency between where it should be if the Earth was flat. So my location is currently still at Null Island. And if I look at the sun's movement for today, this circle with a ring around it, that is where the sun should be over any given ground position. So in other words, it's approaching Madagascar at this point. And as I move it ahead, you can see that it stays along this line of latitude as it circles around for the next day. However, if you're on Null Island, you can see that the sun appears to come in from this direction until it crosses the meridian and then it goes back off in this direction. And then as I explained in the last video, this would be based on where it should be if the Earth was flat using the sun's altitude. This one represents where the sun should be at 69 statute miles for every degree of zenith angle. And the two are not even close to being similar. And this would be true if I move the camera to a different latitude, for example. Let's say I place myself somewhere on the Isle of Man, for example. And over here at this time, the sun should not even reach the ice wall. The observed altitude is 10.9 degrees, which would make it over here. So this is another example of being even more of a problem for flat Earth. The observed altitude of the sun is 10.94 degrees. How high is the sun again on a flat Earth? Is it 5,000 kilometers high? If we have a 10-degree angle and an opposite side of 5,000 degrees, the distance from here to here should be 25,886 kilometers. Flat earthers accept 69 statute miles per degree of zenith angle, which would, in this case, give it a zenith angle of 232 degrees, or an altitude of minus 142. So clearly that doesn't work. So no matter which way I look at it, flat Earth doesn't work at all. So I'm going to go back to the globe projection on the AE map. I'm going to talk about this part now. So as we know, every degree of latitude is 60 nautical miles, or it works out to 111 kilometers per degree. And we know that the sun is at a latitude of 23.059 degrees south. So we add 23 to 90, that gives us 113 degrees times 111 kilometers per degree. That would give this distance from where the sun currently is to the North Pole with a distance of 12,402.5 kilometers. If the Earth is flat, as depicted like this, that would mean that the circumference that the sun would have to travel in a 24-hour period would be 78,492.78 kilometers. We know that the sun does not move at precisely 15 degrees per hour throughout the year, and at this moment in time, the sun has a right ascension drift of 14.9905 degrees. What that means is that because this is less than 15 degrees per hour, the sun is going to drift back as it moves towards the north. Then it'll start speeding up again, and then it will go faster than 15 degrees per hour until it reaches this point, and then it slows down again. And then it continues to accelerate more than 15 degrees per hour until it reaches this point again, and then it starts to slow down again. So at the moment we have a 14.9905 degrees per hour for the sun. We know the distance. We can calculate how fast the sun has to be going at this point in time, and the sun would have to travel 3,269.45 kilometers per hour. I've also done similar calculations for the moon. And so if we look at these numbers throughout the day and throughout the year, we'll see that it's fairly consistent in terms of speed, although it is starting to slow down a little bit more. If we look at it for the next year, you can see 14.995896. So here it's starting to speed up again. Here it has crossed over 15 degrees per hour, and it's still over 15 degrees per hour. And then it's over here, it's slowing down and it's starting to go slower than 15 degrees per hour again. And then it repeats that cycle again. So the other thing to consider is that when the sun is over here, the distance that the sun would have to travel if the sun were rotating above the Earth would be 3,280 kilometers per hour. And as it approaches the Tropic of Cancer, the circumference is almost, although not quite half of what it was in the other tropic, and the speed indicates that it has slowed down proportionally. So this is yet another example of how the flat Earth model breaks. It would mean that the sun is constantly speeding up and slowing down and changing its circuit around this flat Earth. And so here's another thing to consider. Let's say this model isn't quite right. What if this AE map projection isn't the right one? Maybe we should try a different projection. How about we try the South Pole AE map projection? So here's Antarctica and here is North America around the outside. How would that look? So in this case, it's rotating counterclockwise instead of clockwise. And we can see it's really pretty much the same thing. Although I still calculate the distance to the North Pole rather than to the South Pole, it would pretty much be the same thing. And no, maybe that's not quite right. Maybe we should try the equirectilinear map. Is this going to be any better? So here, everything is moving left to right, as one would expect. And all latitudes are evenly spaced vertically. And what if we try projecting where things should appear on a flat Earth? Well, that looks very different, and it now gives me a chance to put out a whole bunch of different other videos with the sun, the moon, and the stars projected on various maps like this. So I'll be able to start making a whole bunch of videos using these other projection maps as well. So look forward to that in the near future. And that's going to be it for now. Once again, if you enjoyed this video, thank you for watching, and I would appreciate the thumbs up, the subscribe if you're not already, etc., etc. You know what to do. Thank you for watching, and I'm going to see you again in another video soon enough. Bye for now.